Hello and welcome to today's edition of Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. It's great to be with you. Today, we're covering some of the most exciting and slightly worrying news from the world of space exploration.
Absolutely. We're going to be talking about a communications breakdown at Mars, a 2 million kilometer tail trailing our own planet, and a brand new mission control center for future rovers.
Plus, we'll dive into what the James Webb Telescope might have found on an exoplanet, a new dual-mode drone from China, and a rocket fairing nicknamed the Hungry Hippo.
It's a busy lineup, so let's get right into it. Anna, why don't you start us off with the news from the Red Planet?
Of course. Our first story is a bit tense. NASA has temporarily, well, we hope it's temporary, lost contact with its MAVEN orbiter. MAVEN, which stands for Mars Atmosphere and Volatile Evolution, has been a workhorse at Mars since 2014.
Right, and it's not just studying the atmosphere, it's a critical communications relay for the rovers on the surface like Curiosity and Perseverance. Losing contact is a big deal.
Exactly. The spacecraft went silent after passing behind Mars from our point of view, which is a standard procedure. But when it should have reemerged and checked in, there was nothing. The team at the Jet Propulsion Laboratory is now working through procedures to try and reestablish a signal.
So what does this mean for the rovers? Are they on their own for now?
Well, thankfully, NASA has redundancy. The Mars Reconnaissance Orbiter and the European Space Agency's Trace Gas Orbiter can also act as relays, so the rovers aren't completely cut off. But losing MAVEN reduces their data downlink capacity significantly.
That makes sense. Spacecraft issues like this happen, and usually the engineers find a way. We're certainly hoping they get MAVEN back online soon.
Fingers crossed. Now for our next story, let's come a little closer to home. Avery, this one sounds like something out of science fiction.
It really does. A new NASA study has confirmed that Earth has a tail. Not a physical one, of course, but a magnetic one, a magnetotail to be precise, that stretches an incredible 2 million kilometers into space.
2 million kilometers. That's more than 5 times the distance to the moon. How is that even formed?
It's created by the interaction between Earth's magnetic field and the solar wind, which is a constant stream of charged particles flowing from the sun. As the solar wind blows past Earth, it stretches our magnetic field out on the night side, just like a windsock.
Right. And this tail isn't empty, is it? It's filled with plasma.
Exactly. It's a plasma tail, and understanding its structure and dynamics is crucial for predicting space weather, which can affect our satellites and power grids. It's a stunning reminder of the complex invisible structures that dominate our corner of the cosmos.
That's fascinating. From invisible tails to very visible new buildings, our next story takes us to NASA's Jet Propulsion Laboratory. They've just opened a new Rover Operations Center, or ROC.
Yeah, this is exciting. This isn't just a shiny new room with more computers. The ROC is designed to be the heart of future robotic missions to the Moon and Mars. It's built to handle multiple missions simultaneously.
And it incorporates some cutting-edge technology, including advanced AI to help rover drivers plan their routes and analyze data more efficiently. They're also emphasizing partnerships with commercial space companies.
That partnership piece is key. With programs like Artemis aiming to return humans to the moon and more ambitious Mars missions on the horizon, NASA needs a central hub that can coordinate between its own assets and those of its commercial partners. The ROC is that hub. It's basically mission control for the next generation of explorers.
Speaking of next-generation explorers, our next story comes from the James Webb Space Telescope, which is continuing to rewrite our understanding of distant worlds.
I love a good JWST story. What has it spotted now?
It's been looking at the TRAPPIST-1 system, which you'll remember as a system of 7 rocky, Earth-sized planets orbiting a small star. JWST focused on TRAPPIST-1e, a planet in the habitable zone, and the data hints at the possibility of a methane-rich atmosphere.
Wow, methane. On Earth, that's often associated with life. But the key word here is hints, right?
Precisely. The data is still ambiguous. Scientists are quick to point out that methane can also be produced by geological processes, not just biological ones. The signal is also faint and could be an instrument artifact or something else entirely.
So it's not time to announce aliens just yet.
Not just yet, but it is an incredibly tantalizing result. It shows that JWST is capable of detecting potential biosignatures on rocky exoplanets, which is exactly what it was designed to do. More observations are already planned to get a clearer picture.
It's amazing to watch science unfold in real time. And while JWST looks out, other nations are looking at new ways to explore up close. Our fifth story is about a new type of Mars drone being developed in China.
We all remember the success of NASA's Ingenuity helicopter. This new concept takes that a step further. Chinese scientists are designing a drone that can both fly and roll on the Martian surface.
Fly and roll? So it's a transformer?
In a way, yes. The idea is to conserve energy. Flying in Mars's thin atmosphere takes a lot of power. So the drone would roll on its wheels for long-distance travel across flat terrain and only use its rotors to fly over obstacles or explore hard-to-reach areas like canyons or cliffs.
That's a very clever solution. It combines the endurance of a rover with the agility of a helicopter.
It is, and the design could even allow it to enter and explore Martian lava tubes or caves, something no previous mission has been able to do. It's a concept that could dramatically expand our exploration capabilities on other worlds.
That is a fascinating concept. It really shows how we're getting smarter about exploring other planets.
It's certainly an exciting time in space innovation.
All right, for our final story, let's talk about getting to space in the first place. This one involves Rocket Lab and a piece of hardware with a fantastic name, the Hungry Hippo fairing.
I was waiting for this one. This is about their upcoming Neutron rocket, which is designed to be fully reusable. The fairing is the nose cone that protects the satellite during launch. Typically, fairings are just jettisoned and fall into the ocean.
Right, which is wasteful. SpaceX recovers theirs with nets on ships, but Rocket Lab has a totally different approach. The Neutron's fairing isn't jettisoned at all. It's integrated into the first stage of the rocket.
So how does the satellite get out?
This is the brilliant part. The fairing petals open up like a giant clamshell or a hungry hippo to release the payload. Then they close again before the entire first stage returns to Earth for a landing. Rocket Lab just completed successful tests of this mechanism.
That's an elegant piece of engineering. It eliminates the entire process of fairing recovery at sea. It just comes back with the booster.
It's a huge step towards rapid reusability, which is the key to lowering the cost of access to space. A very cool innovation to watch.
And that's all the time we have for today's news roundup. From a silent orbiter at Mars to a hippo-like rocket here on Earth, it's been another busy time in space.
It certainly has. Thank you all so much for tuning in to Astronomy Daily. You can find us wherever you get your podcasts, and we'd love it if you'd leave us a review. Join us next time as we take a dive into more mysteries from deep space.
Until then, keep looking up.